Picture this: a telescope so powerful, the story of the cosmos, unveiling secrets that make even the most seasoned astronomers question everything they thought they knew. The James Webb Space Telescope, humanity's most advanced eye on the universe, has peered into the deepest reaches of space and time, and what it's found is nothing short of staggering. Strange galaxies that shouldn't exist, cosmic signals that defy our understanding, and hints that our universe might not be the singular, one-of-a-kind phenomenon we've always believed. A Nobel Prize-winning scientist has sounded the alarm, declaring that these discoveries point to a reality far stranger than we ever imagined, a universe that could be just one piece of an infinite, mind-bending puzzle. Buckle up, because today we're diving into the jaw-dropping revelations from Webb, exploring why these findings are shaking the foundations of cosmology and what they mean for our place in the cosmos. This isn't just a story about stars and galaxies, it's a tale of existence itself, one that will leave you questioning the very nature of reality. Let's start with the telescope that's turning the scientific world upside down. Launched in December 2021, the James Webb Space Telescope is a marvel of human ingenuity, designed to capture light from the earliest moments of the universe. Its golden, honeycomb-like mirror spans over 21 feet, collecting infrared light that's been traveling for billions of years. This allows Webb to see farther and deeper than any telescope before it, peering back to a time when the universe was just a fraction of its current age. Scientists expected Webb to refine our understanding of the cosmos, filling in gaps left by its predecessor, the Hubble Space Telescope. But instead of confirming existing theories, Webb has unleashed a torrent of surprises that are forcing researchers to rethink the rules of the universe. From galaxies that are too big, too bright, and too old to exist, to mysterious signals that hint at cosmic cycles beyond our wildest dreams, Webb is showing us a universe that's stranger, more complex, and more awe-inspiring than we ever dared to imagine. One of the most shocking discoveries came when Webb turned its gaze toward a patch of sky near the constellation Ursa Major. There, it spotted faint glimmers of light that had been racing across space for over 13 billion years. These weren't just any lights, they belonged to galaxies formed just 500 million years after the Big Bang, a time when the universe was still in its infancy. According to everything we thought we knew, these galaxies should have been small, dim, and barely formed, struggling to coalesce in a chaotic, primordial soup. But what Webb found was the opposite. These galaxies were massive, rivaling the size of our own Milky Way, and brimming with stars. This is a cosmic scandal of the highest order. The early universe simply didn't have enough time or material to build such colossal structures, or so we thought. Astronomers have dubbed these galactic giants universe breakers because they shatter the models we've relied on for decades. How could something so enormous form so quickly? It's like finding a fully built skyscraper in a town that's only been around for a week. The implications are staggering. Either our timeline of the universe is wrong, or something else, something unknown, is at play. These universe breakers aren't just big. They're also far too rich in stars for their age. Stars take time to form, requiring gas clouds to collapse under gravity, ignite nuclear fusion, and stabilize. In the early universe, this process should have been slow, limited by the sparse availability of ordinary matter. Yet Webb's images show galaxies teeming with stars, some just 300 million years after the Big Bang, glowing with an intensity that defies logic. This isn't a minor glitch in our understanding, it's a full-blown crisis. Researchers are scrambling to explain how these galaxies could have produced so many stars so quickly. One possibility is that the early universe was far more efficient at star formation than we realized, perhaps driven by unknown forces or conditions. Another, more radical idea is that these galaxies aren't as young as they seem. What if they're relics from a time before our universe, as we know it even began? This idea, once dismissed as science fiction, is gaining traction thanks to a Nobel laureate's bold theory that the universe might be part of an eternal cycle of birth, death, and rebirth. This brings us to one of the most provocative ideas in modern cosmology: the notion that our universe isn't a one-time event, but part of an infinite cosmic saga. A Nobel Prize-winning physicist has proposed that the Big Bang wasn't the absolute beginning, but rather a big bounce, a transition from a previous universe to ours. In this view, the universe expands, decays, and collapses, only to be reborn in a new cycle, over and over, forever. This cyclic model challenges the traditional narrative of a singular Big Bang, suggesting that the cosmos has no true beginning or end. What makes this theory so electrifying is that it's not just speculation, it's backed by tantalizing evidence. In the cosmic microwave background, the faint glow left over from the Big Bang, researchers have spotted mysterious patterns, circular hotspots that don't fit the standard picture. These anomalies, dubbed Hawking points, are thought to be the echoes of supermassive black holes from a previous universe. As those black holes evaporated, they released energy that carried over into our cosmos, leaving faint imprints in the sky. Webb's discoveries are lending weight to this idea, as the telescope's observations of ancient galaxies and unexpected cosmic phenomena align with predictions from cyclic models. Could we be living in the shadow of a universe that came before ours? The universe breakers aren't the only shockers Webb has uncovered. Another bombshell came when the telescope detected a galaxy called JWST 11, shining brightly just 330 million years after the Big Bang. This galaxy wasn't just glowing, it was blasting out intense ultraviolet radiation, far more than scientists thought possible for such an early time. When researchers analyzed its light, they found a telltale signature known as Lyman alpha radiation, a marker of energized hydrogen. This was a game changer. According to our models, the early universe was shrouded in a thick fog of neutral hydrogen gas, which should have absorbed or scattered ultraviolet light, preventing it from escaping. Yet, here was JWST 11, its light cutting through the cosmic fog like a beacon. This shouldn't have happened for another few 100 million years. When the universe's first stars and galaxies began clearing the fog in a process called reionization. The discovery suggests that reionization, the moment when the universe went from dark to light, happened earlier or faster than we ever imagined. It's as if the universe flipped on its lights long before the electrician was supposed to arrive. The lead astronomer on the JWST 11 study was flawed by the findings. This galaxy is rewriting the history of the early universe, they said. Its light shouldn't be able to escape, yet it's reaching us loud and clear from a time when the universe was just a toddler. The data revealed that this galaxy had carved out a massive bubble of ionized gas, stretching over 650,000 light-years. This bubble allowed its ultraviolet light to travel freely, a feat that should have taken far longer to achieve. The implications are profound. Either our understanding of ionization is fundamentally flawed, or something extraordinary was happening in the early universe. Could smaller galaxies, previously overlooked, have played a bigger role in lighting up the cosmos? Or was this galaxy powered by something unexpected, like a hyperactive black hole or a population of ultra-hot stars? Whatever the answer, one thing is clear. The universe is full of surprises, and Webb is exposing them one by one. But the shocks don't stop there. Webb's discoveries are also casting doubt on another pillar of cosmology: the rate at which the universe is expanding. For decades, scientists have relied on the Hubble constant to measure this expansion, expecting a steady rate of about 67 kilometers per second per megaparsec. But when they measure it, using real-world data, supernovae, red giant stars, gravitational lenses, the number jumps to 73 kilometers per second per megaparsec. This discrepancy, known as the Hubble tension, has been a thorn in the side of cosmologists for years. Webb's ultra-precise observations were supposed to resolve the issue, but instead they've confirmed the mismatch and deepened the mystery. Why doesn't theory match reality? Some researchers are proposing a radical solution. Our universe might be interacting with others. Imagine our cosmos as a bubble in a vast multiverse, colliding and merging with neighboring universes. These interactions could stretch and distort our universe, making it appear to expand faster than expected. Mathematical models of this multiverse scenario are starting to align with Webb's data, suggesting that the telescope might be picking up the first clues of a cosmic network far grander than we ever dreamed. This multiverse idea is more than just a wild theory. It's gaining serious traction. When scientists ran simulations of universes merging, they found that the resulting expansion rates matched observations better than the standard model. This is a seismic shift in how we think about the cosmos. If true, it means our universe isn't a solitary island, but part of a sprawling, interconnected tapestry. Every galaxy, every star, every planet might owe its existence to the dance of multiple universes colliding and reshaping one another. Webb's ability to detect ancient galaxies and measure cosmic expansion with unprecedented accuracy is providing the first real evidence for this mind-boggling possibility. It's a humbling reminder that our understanding of the universe is still in its infancy, and nature has a way of upending our best-laid plans. Let's take a step back and consider what all this means. The universe, as we know it, began 13.8 billion years ago with the Big Bang, a colossal explosion that set everything in motion. At least, that's the story we've told ourselves. But Webb's discoveries are forcing us to question that narrative. The universe breakers, with their impossible size and star power, suggest that the early cosmos was far more active and complex than we thought. The early ionization, seen in galaxies like JWST hints that the universe's timeline might be off, or that unknown forces were at work. And the Hubble tension, now more pronounced than ever, points to a cosmos that might be shaped by interactions with other universes. Together, these findings paint a picture of a universe that's not just bigger or older, but fundamentally different from what we imagined. It's a universe where the rules we wrote don't always apply, where the impossible becomes possible, and where the past might hold secrets we're only beginning to uncover. Now let's dive deeper into the cyclic universe theory, because it's one of the most thrilling ideas to emerge from these discoveries. The Nobel laureate behind this concept argues that the Big Bang was just one chapter in an endless story. In this model, the universe expands until all matter decays into pure energy, light without mass. In this strange, timeless state, the universe loses its sense of scale, and the conditions for a new Big Bang emerge. It's a cosmic reset button pressed over and over across eternity. What's truly astonishing is the evidence supporting this idea. Those Hawking points in the cosmic microwave background aren't just random noise, they're potential fingerprints of a previous universe. Each point could mark the spot where a supermassive black hole from an earlier cosmos evaporated, sending a burst of energy into ours. These points appear as faint disks about the size of the full moon, scattered across the sky. Data from multiple satellites have confirmed their presence, and while skeptics argue they could be statistical flukes, the patterns are hard to dismiss. If they're real, they're the most direct evidence we have that our universe is part of a grand, eternal cycle. This cyclic model isn't just about the distant past. It has implications for the future too. If the universe is destined to decay and be reborn, what does that mean for us? Will humanity, or whatever comes after us, leave its own cosmic fingerprints for the next universe to find? It's a question that blends science with philosophy, forcing us to confront our place in the grand scheme of things. The idea of an eternal cosmos is both humbling and exhilarating, suggesting that existence is far more resilient and dynamic than we ever imagined. And Webb's discoveries are bringing this idea closer to reality, showing us that the universe is full of clues about its past and perhaps its future. But let's not get too lost in the big picture. Webb's findings are also rewriting the story of how galaxies formed and evolved. In the early universe, galaxies were thought to grow slowly, starting as small clumps of gas and dust that gradually merged to form larger structures. But the universe breakers tell a different story. These massive, star-packed galaxies suggest that galaxy formation was a much faster, more chaotic process than we realized. Some researchers speculate that the early universe was a hotbed of intense activity, with gas clouds collapsing at breakneck speed to form stars and black holes. Others propose that these galaxies might have been seeded by exotic objects, like primordial black holes, that acted as gravitational anchors, pulling in matter at an unprecedented rate. Whatever the explanation, it's clear that the early universe was a far more dynamic place than our models predicted, and Webb is giving us a front-row seat to this cosmic drama. Another puzzle is the role of black holes in these early galaxies. Many of the universe breakers show signs of hosting supermassive black holes, millions or even billions of times the mass of our Sun. These black holes are thought to power quasars, incredibly bright objects that outshine entire galaxies. But here's the catch. Black holes take time to grow, accreting matter over millions of years. How could such massive black holes exist in galaxies that are just a few 100 million years old? One theory is that these black holes formed directly from the collapse of massive gas clouds, bypassing the slow growth process. Another possibility is that they're relics from a previous universe, carried over through the Big Bounce. If true, these black holes could be the ultimate cosmic heirlooms, connecting our universe to one that came before. Webb's ability to detect the infrared signatures of these black holes is helping researchers piece together their origins. But for now, they remain one of the universe's greatest enigmas. The emotional weight of these discoveries can't be overstated. For centuries, humanity has looked to the stars for answers, seeking to understand our origins and our place in the cosmos. The Big Bang Theory gave us a comforting narrative, a singular moment when everything began, a clear starting point for the universe and for us. But Webb's findings are upending that story, replacing it with something far more complex and mysterious. The idea that our universe might be just one of many, or part of an eternal cycle, is both thrilling and unsettling. It forces us to confront the possibility that we're part of something much bigger, something we may never fully understand. Yet there's beauty in this uncertainty. It reminds us that the universe is still full of wonders waiting to be discovered, and that our journey to understand it is far from over. As Webb continues to scan the heavens, each new observation adds another piece to this cosmic puzzle. The telescope's ability to capture light from the universe's earliest moments is giving us a window into a time when the cosmos was still taking shape. But with every answer comes a dozen new questions. Why are these early galaxies so massive? How did they form so quickly? What powered their intense light? And what do these discoveries tell us about the ultimate fate of the universe? Researchers are working tirelessly to find answers, using advanced simulations, mathematical models, and ground-based telescopes to complement Webb's data. But one thing is certain: the universe is far stranger than we ever imagined, and we're only scratching the surface of its secrets. Let's zoom in on another fascinating discovery: the role of dark matter in the early universe. Dark matter, that mysterious substance that makes up about 27% of the universe's mass, is thought to have played a key role in galaxy formation. Its gravitational pull helped gas and dust clump together, forming the seeds of the first galaxies. But the universe breakers are so massive that they challenge our understanding of how dark matter works. According to standard models, dark matter should have been spread thinly in the early universe, limiting the size of early galaxies. Yet these galaxies are far larger than expected, suggesting that dark matter might have clumped more efficiently, or that something else was at play. Some scientists are exploring the idea of fuzzy dark matter, a hypothetical form that behaves more like a wave than a particle, allowing it to concentrate in ways that traditional dark matter can't. Others are considering the possibility that dark matter interacted with ordinary matter in unexpected ways, fueling the rapid growth of these early galaxies. Webb's observations are providing critical data to test these ideas, but for now, dark matter remains one of the universe's biggest mysteries. Then there's the question of dark energy, the force driving the universe's accelerating expansion. Dark energy makes up about 68% of the universe, yet we know almost nothing about it. The Hubble tension, confirmed by Webb, suggests that dark energy might not be as constant as we thought. Some models propose that dark energy evolves over time, becoming stronger or weaker as the universe ages. If true, this could explain why the universe appears to be expanding faster than predicted. Other theories suggest that dark energy is influenced by interactions with other universes, tying back to the multiverse idea. Webb's precise measurements of distant supernova and galaxy clusters are helping researchers probe the nature of dark energy, but the answers are still elusive. It's a reminder that the universe is governed by forces we barely understand, and that even our best theories are just approximations of a deeper truth. As we grapple with these mysteries, it's worth reflecting on the human side of this story. The scientists behind Webb's discoveries are driven by a passion for knowledge, spending years analyzing data, building models, and debating ideas. They're not just chasing facts, they're chasing a deeper understanding of existence itself. Their work is a testament to the power of human curiosity and a reminder that even in the face of the unknown, we keep pushing forward. The discoveries from Webb are a collective achievement, involving thousands of engineers, astronomers, and researchers from around the world. Together, they've given us a new perspective on the universe, one that's both humbling and inspiring. But what does all this mean for you, the viewer? Why should these distant galaxies and cosmic cycles matter to your life? At its core, this story is about more than just science. It's about who we are and where we come from. The universe isn't just a backdrop to our lives, it's the stage on which all of human history has played out. Every atom in your body was forged in the hearts of ancient stars, billions of years ago. The discoveries from Webb are a reminder of that connection, showing us that we're part of something vast and magnificent. They challenge us to think bigger, to question our assumptions, and to embrace the unknown. In a world that often feels divided and uncertain, the universe offers a sense of unity and wonder, reminding us that we're all part of the same cosmic story. As we look to the future, Webb's mission is far from over. The telescope is expected to operate for at least a decade, delivering a steady stream of data that will continue to reshape our understanding of the cosmos. New instruments, like the upcoming Nancy Grace Roman Space Telescope, will complement Webb's work, providing even more detailed views of the early universe. Meanwhile, ground-based observatories are ramping up their efforts, using advanced techniques to study the cosmic microwave background and search for more evidence of cyclic universes. The pace of discovery is accelerating, and we're on the cusp of a new era in cosmology, one that could redefine our place in the universe. So what's the takeaway from all this? The James Webb Space Telescope has shown us that the universe is a place of endless surprises, where the impossible becomes possible and the familiar becomes strange. Its discoveries are challenging our deepest assumptions, forcing us to rethink the story of the cosmos and our place within it. From universe-breaking galaxies to hints of cosmic cycles, from the mysteries of dark matter to the enigma of dark energy, Webb is revealing a universe that's more complex, more dynamic, and more awe-inspiring than we ever imagined. It's a reminder that the pursuit of knowledge is a journey, not a destination, and that every new discovery brings us closer to understanding the true nature of reality. So the next time you look up at the night sky, remember, you're not just seeing stars. You're seeing the echoes of a universe that might be far older, far stranger, and far more connected than we ever dreamed. And that, more than anything, is what makes this cosmic adventure so breathtaking.